This is the second part of our supplementary material for section 2.2. I don't know where I got cut off on the last lecture. Sorry about that. I wasn't paying attention to my time. So I believe that I got caught off explaining that 66 2/3 was another way of expressing the 0.666 repeating. And it's very useful to know some of these conversions because if we don't know that 2/3 is a representation of 0.666. If we wanted to go the opposite way of having a decimal and getting back to a fraction, we'd never be able to do it without some techniques from more advanced mathematics. So knowing those conversions is quite important, which brings me to the next thing that we're going to do, which is converting a fraction into a decimal or a percentage into a fraction. And since our percentages are kind of the farthest away from a fraction that we can get, I'm going to start with percentages. So example 3 here, we're starting with the percentages. So in example 3, we have 25%. So to get this back into a fraction, the first thing we're going to do is we're going to read the percent as a part of 100. So in part A here, we have 25 and percent reads as parts of 100. Now we can't just leave it as that. We already know that that is an unreduced fraction, so we have to reduce it. 25 is divisible by 25, and so is 100. That is what we call the greatest common factor between 100 and 25. So we have division there, and that's going to reduce this, and this gets us back to a 1 in the numerator and a 4 in the denominator. And we see that that was quite an easy little translation from percentage to a fraction. And then the next one is 89.45 as a fraction. And so I'm going to do that one on my second page here because I'm going to run out of room. So we have 89.45%. So we have 89.45, and that's parts of 100. Now we don't allow decimals in a fraction, so what we have to do is we have to be able to move this decimal out of here. So we're going to multiply both the numerator and the denominator by 100 so we can get that decimal out of there. So that's one way that we could do this. Okay, now that's actually a more complicated way, and that gives us 8945 over, and then we have 100, and then from the second 100 we get two more two more zeros. Now that is a way of reading multiplication by factors of 10 by counting up the zeros. We'll run into that a little bit later, as well as something called scientific notation. Now on this particular one, we could also convert 89.45 to a decimal. So 89.45 converted into a decimal representation from a percent, we would move that decimal 2 places to the left to take out the 100ths that are put in here artificially with the percentage. And so now we would have 0.8945, and that is our decimal. And now we could get from here to here by reading this. This place value is tenths, hundredths, thousandths, 10,000ths. So we're going to read it as 8,945 10,000ths, and 10,000ths is the denominator that you see up here, 8,945 10,000ths. So that's another way of going about it. And then of course once we get here, we're going to have to reduce this. So I see that they're both divisible by a 5, and so I'm going to take a 5 out of both of them, and then from there I'd see, can I get down any further? And so we have 5 goes into 8 one time with 3 left over, 7 times with 4 left over, 8 times with 4 left over, and then we have 9, and then 5 will go into 10 2 times, 5 will go into 0 0 times, 0 times, 0 times. And then I want to see if there's anything in common. Well, this obviously is made up of 2's and 5's. This is not